Okay, now let us consider an example of using loops. So to find the square root of a number. Loop number square root. So loops are often used in programs that compute numerical results by starting with an approximate answer and iteratively improving it. Iteratively loop to loop to iteration to iteratively improving it. Loop se numerical calculation numerical calculation approximate value hanjan loop set values improve we start with an approximate value, then we perform the looping repeatedly, and in each loop the value increases and the value moves closer and closer towards the correct value. For example, one way of computing square roots is by Newton's method. Suppose that you want to find the square root of a numbers a have a numbers square root if you start with almost any estimate approximate value estimate x have any approximate estimate x you can compute a better estimate with the following formula. Next estimate, first estimation x, next estimation y. First estimate x x plus a divided by x then answer to the you divide by 2. This will give you a value which is y and which is the next estimate. X values y values this is a better estimate to the exact value. So a line about value example, to find the square root of 4. Square root of 4 so we already know that the square root of 4 is 2. Method Newton's method function we have the loop how can we get better and better estimate. So a is 4. A is 4. 4 high numbers assigned to estimate 4 square root say let us start with some estimate x equals 3. X equals 3 estimate. Next, formula y equal to x plus a by x divided by 2. Y equal to x plus a by x then value to the 2 and divide they will give you y. And this gives a new estimate which is closer to the answer than the original estimate 3. Formula calculate I will get a value of y which is closer to the real value 2 as compared to the value x. X is y is an accurate better estimate. So let me run this. So when x equal to 3, y equal to 2.166666665. So from this we see that the first estimate is x equal to 3 and the second estimate is 2.16666 and so on. So the second estimate is better than the first estimate. That means the second estimate is closer to the exact answer as compared to the first estimate. 3 is 2 next step process if I do it repeatedly I will get more and more correct answer. More and more correct I'll get closer and closer to the correct answer. This result is closer to the correct answer too. So if we repeat the process with a new estimate, it gets even closer. So Hoziki value is 2.166 high say y value do x x already y policy let us calculate the new value of y which will be better than this value of y. 2.1666 high y value is the estimate using this formula. So you start with the new estimate that is 2.1666, and then you calculate this value x plus a by x divided by 2. So x is y value, then you will get a new value of y which is closer to the correct answer than this value. So let me run this cell. 2.0064. Closer, so this becomes closer to the correct answer too. Estimate new estimate by using the same calculation. So what are we doing? We are repeating this calculation again and again. Y equal to x plus a by x divided by 2. We are repeating this calculation again and again by using the latest value of the estimate. So let me run this again. Get a more precise answer. 2.0064 and 2.0000. Starting estimate better estimate you get better answer. Starting estimate let us find a better answer, better estimate again. Finally, you come to the correct value 2. So you see here, what have we done? We have performed this calculation again and again. Calculations we get more and more precise answer. Ultimately, we get the correct answer. Same calculation loop idea. In general, we don't know ahead of time how many steps it takes to get to the right answer. But we know when we get there because the estimate stops changing. Calculation value change or so when I run this cell again, my value change or number of steps to get the right answer. But we know that we get there. The right answer, the value of the estimate stops changing. Change all right. So we have got the right answer. Say so the old estimate and the new estimate, they are the same. When the new estimate is equal to the old estimate, we can stop. Here is a loop that starts with an initial estimate x and improves it until it stops changing. Programs 1, 2, 3, 4, 5, 6 times. I can write a simple while loop. Simple while loop. Same process to program. Because we are performing this calculation again and again. So this is the while loop. Let us look at the program. A equals 4. So we want to find the square root of the number 4. What is our initial estimate? Our initial estimate is 3. We can try 3.1. 3.1 while true, while true, print x. First estimate to print out. 1 minute. So here, while true, print x. The first estimate is printed. Next step to we find a better estimate for the root by using this formula. Next step, if y is equal to x, previous estimate to new estimate manaradi break toro. you exit the loop. Manadragadi pedore sigi new estimate se amuk x the assign toxalo, and then you print that value of x, and then you perform this operation again. Aduna sigi while loop sigi body your statement 1 2 3 4 5 statement manga sina high sticker high you perform this operation again and again until the value of the estimate stops changing. So let me run this. We start with the initial estimate. 3.1 next estimate 2.195, next 2.008675, next 2 point this, next this. Ultimately we get to the correct value. Starting with the initial estimate. We can start with an estimate which is far away from the true answer. True answer is 4 square root 2 2 10. Let us start with 10 and let me run this program again. So 10, 5.2 and 2.9. Ultimately 2 stop. 1, 2, 3, 4, 5, 6 times. So I can write a small loop, and this small program will perform the function. Will perform the functions. Will perform the steps which we have done earlier. So the steps character 1, 2, 3, 4, 5, 6, 7, 8. 8 times story high. 8 times story finally stop over. For most values of A, this works fine, but in general, it is dangerous to test float equality. Y is equal to X is the test. If Y is equal to X condition, floating point number ani test this is dangerous because floating point values are only approximately right. When the computer stores floating point numbers, they are stored as approximate values, and most rational numbers like 1/3 and irrational numbers like square root of 2 cannot be represented exactly with a float. Rational numbers, irrational numbers, the floating point when exact when stored to floating point and check we may have situations where this never happens. Y equal to X condition is Y equal to X condition. We may come across a situation where the value of Y is never equal to the value of X, because both of them are floating point numbers, and floating point numbers are normally stored as approximate values. Rather than checking whether X and Y are exactly equal, it is safer to use the built-in function absolute value ABS, absolute value, to compute the absolute value or magnitude of the difference between them. X ko Y ga manabra na yeng thibagi mahuta X ko Y ga gi mamarukta lagi difference kayam chawri ge do adu yeng bana hena safe way. Let us look at the next program. Sigi program here A is 2. A is 2 have you know? This program is almost equivalent to this program, except that we have made some changes. Sigi break the condition. Instead of this condition, we'll use another condition, and then here we wanted to find the square root of 4. Now we want to find the square root of 2. 2 is square root of 4. Initial estimate X equals 3 log 5 log the epsilon let us define a new quantity, new variable epsilon, that is 0.00000001. This is a very small quantity. This is a very small quantity. 0.000001. Second loop lasi while true print x ki initial estimate to print or then you use this calculation y equals x plus a by x by 2 sigi calculation jam to next if the absolute value of y minus x is less than epsilon break to hai ko aduna a condition ji x ko y ga manabra haina check to gi mahuta if the difference between x and y is less than this value the abs have the difference to negative number type I got this difference can be a negative number so you take the absolute value so if the absolute value of the difference between these two numbers is less than this so again pick to the break because this is the accuracy that we want I see about I 1 2 3 4 5 6 7 8 8 decimal place of the uneasy manner uneasy difference aduna 8 decimal place of the manner I yare adu value do I accurate point and load again I see looks a break to so let me run this by starting from 3.5 3.5 let me run this character loop say 1 2 3 4 5 6 this loop is executed 6 times okay so the loop says 6 times execute and ultimately at this value 1.414 this is up to 8 decimal place of the answer anise manner so for example this is the first decimal place second decimal place third fourth fifth sixth seventh eighth so 1 2 3 4 5 6 7 8 5 6 Matangi next iteration da so 6 is x or so x equal to y and 6 is x or is print or this is x we find a new value of y new value of y to y do say that 6 up to 8 decimal place manner that new value of the estimate is equal to this earlier estimate up to the 8 decimal place therefore we break from the loop this is accurate up to the 8 decimal place from to the so let us look at another example this is simple example loop example makalamani isam chami Celsius eva table lamadagi Fahrenheit convert over starting the quite first line print Celsius to Fahrenheit conversion table same to never Celsius Fahrenheit convert over this is a table heading C equal to -20 this is the starting value of the temperature in Celsius DC change in C is 5 this is -20 degi auraga 5 some increase plan -20 degi auraga -15 -10 -5 0 5 10 plan while C is less than or equal to 40 C is now less than or equal to 40 sigi statement execute F Fahrenheit convert by using this formula F equals 9/5 times C plus 32 print C की value print F की value print separated by a tab space amana separate C की value to print F की value to print next step you increase the value of C by DC was at 5 so in the first loop the original value of C was -20 so C is -20 is less than 40 this is true already these three statements will be executed F to convert over -20 corresponding value of F to colony -20 ga my corresponding value F to print over next step C the value of C is increased by DC -5 so -20 da 5 tinjalo -15 -15 zero loop condition to check -15 less than 40 true statement execute so quite last -10 minus 10 less than 40 amuk check taroni true kare adana smaina as long as this condition is true you execute these three statements han statements na Fahrenheit convert tore ani subo statements na Celsius ki value duga Fahrenheit ki value duga print tore mathang dana cg increment tore c ki value by 5 step of 5 the quite last print dot line se kaino table lu loire na sum line ma option bane this is not necessary so last ki print this is not necessary yang badan why na sum option bani ko this is not important so let me run this cell you get this corresponding the Celsius value separated by 5 unit by steps of 5 and the corresponding Celsius values Fahrenheit values this is the temperature in Celsius this is the temperature in Fahrenheit separated by a tab space see uneasy tab space layer separation so 40 is someone let us say 20 20 so yeah so in the above program first we define the start value of the sequence of Celsius temperature that is c equal to minus 20 we also define the increment dc that will be added to c inside the loop when we enter the loop condition c is less than or equal to 40 let me change it to 20 don't forget that's okay this is 20 oh adum laser sunu onthoro ge jaga ani hum thono onthona kanadre see 40 doesn't lay rank colors see this condition let us keep it at 40 the first time c is 20 which implies that c is less than 40 equivalent to c less than equal to 40 in mathematical notation it's true and since the loop condition is true we enter the loop and execute all the indented statements next that is indented statement that is we compute f corresponding to the current c value print the temperatures and increment c by dc thereafter we enter the second pass in the loop sinjiko han buduna first pass loop ki han buduna first pass kore ani su buduna second pass kore therefore we enter the second pass in the loop first we check the condition c is minus 15 and c is less than equal to 40 this is still true we execute the statement in the indented loop block c becomes minus 10 this is still less than or equal to 40 so we enter the loop back so when third pass fourth pass this procedure is repeated until c is updated from 40 to 45 in the final statement in the loop block ultimately c is in 40 whatever when ultimately c is in 40 whatever c less than equal to 40 true whatever this c execute print next c equal to c plus 5 c becomes 45 in this step c becomes 45 whatever condition test over 45 less than equal to 40 false to the loops exit torani print this line so print this line c is in 45 when we test the condition c less than equal to 40 this condition is no longer true and the loop is terminated and we proceed with the next statement that has the same indentation as the while statement which is the final print statement in the example so while loops while chap manana indent over chap manana indent over statement tiro print tare sidala ane while loops exit taragadi maga chap manana indent over the print statements so this is another example of how a loop is used on example a loop is used to find the square root of a number and a loop is used to generate a table of conversion from Celsius to Fahrenheit. There we go. Sum of 1 to 100. So we are using this loop to find the sum of numbers from 1 to 100, integers from 1 to 100. Sum variable defined values is 0 and initialized. This is initialization. Sum we define a variable sum and the value 0 is stored in the variable sum. Next I equal to 1. How I equal to 1 initialized because We want to add from 1 to 100. I equal to 1 thame. While I is less than or equal to 100, sum equal to sum plus I. So initially 0 0 I give value 1 tinjale aduga sum da hapsale. So sum value kya tare 0 plus 1 1 tare 1 is sum da hapsale. Next step ta I equal to I plus 1. So I is kya no, so 1 remember say plus 1 tore 2 tare ko. This becomes 2. Loops ta ulai 2 less than equal to 100. Yes. Sum equal to sum plus 2. Sum do kya lagi bano 1 lagi bani ko 1 plus 2 tore 1 plus 2 3 3 ji amu sum da assign to sale. So now sum becomes 3. Next step ta 2 ji I 2 ogibudu 2 plus 1 3 tare. So 3 ji amu less than 100 lere. So ma reading sai sum do kya lagi bano 3 lagi bani 3 to the 3 u tijalo kya tare 6 tare ko. Next step ta I ji amu 4 the update tore 4 is less than 100. So ma already 4 tijale smite tawdana. In each pass of the loop, the next integer is added. 1 add tore, 2 add tore, 3 add tore, 4 add tore, and so on. This addition will continue till I is equal to 100. I is equal to 100 for add tore. When I equal to 100, so 100 for the add tore. After that, it becomes 101. 101 or 101 though this condition is checked over 101 less than equal to 100. No, this condition becomes false. So we come back, we exit the loop and we get to the print statement. Print sum equal to sum value though. So the printer unable. So let me run this cell. It should give you 5050, which is addition from 1 to 100. So mine we can find the Fibonacci series. Fibonacci series a series of numbers in which each number is the sum of the two preceding numbers. Fibonacci series is 1 1 1 1 1 1 plus 1 kya tare 2 tare 2 plus 1 kya tare 3 tare 3 plus 2 kya tare 5 tare 5 plus 3 kya tare 8 tare, and so on. So each number is the sum of the two preceding numbers. This is Fibonacci number. Correct? A the 0, B the 1 assigned tore, while B is less than 1000. Print B sigi n attributes space and period. So this Fibonacci numbers will be separated by spaces. The new line the print or same single line the print only separated by spaces. Next kadore sigi B value kya B value 1 lagi B value 1 lagi A the hapsalo adri sai A value kya lagi 0 B kya lagi 1. So 0 plus 1 1 tare sijna B the hapsalo siniko sigi statement sigi meaning di sigi B value A the hapsalo adudagi hana lagiba this A is not the new value A. New value A do not hana lagiba A value duniba sigi 0 1 0 1 sigi 0 hapsalo the 1 hapsalo A plus B phangiba value do B the hapsalo haiba. So let us run this cell. This will give you the Fibonacci series. Sigi particular programs you need to sit back, look at the program and think. You need to think about this. Sigi bakal khan bachangani aduna sigi I explain tawroi yum the khallo aduga sigi programs understand tawri yango. Correct? So the su another term yauri here we are using a new term, that is import math. Import math have module we have math module. Math have a module programs Python masamakta square root haiba function je yaudeba ko natraga factorial haiba function je yaudeba aduna aina factorial haiba function je aina Python this sizinnaringagadi factorial haiba function je define tawba library ama changeba factorial haiba function je define tawba library du koina kari kawi maths module kaweba maths maths module kaweba ko aduna adugi library do hana pusala ani adugi library do yawriba maths.factorial haibodo maths.factorial haidi keno sigi math haibo module ji do yawriba factorial haibo function do neba mana kawise yani ko aduna math haibo module ji ki manung do yawriba factorial haibo function ji mana kawraga this is how you calculate factorial in Python. In Python. Aduna sigi programs in this is a program to calculate the expansion of sine. Sine x adi sine x adi x minus x cubed by 3 factorial plus x to the power 5 by 5 factorial minus x to the power 7 by 7 factorial and so on. Like adigi sine series to sedida program dorga poliba yare ko siju noi hapet phamdaraga fazana khallo aduga sigi gyan lakani adudagi sigi sidana square root using module math module siju masagi math module kawraga square root hotpa aduna from math import square root math hariba module jidagi square root hariba method hai Computational method have the function have ni ko math hariba module judagi square root hariba method to import tawro ko adi square root hariba function je Python masagi the built in oine yawjadeba aduna aina square root hariba function je sina ge harigadi ai kedoroni math hariba module dugi manungda yawriba square root hariba method to adu aina call tawbane method have the function have ni ko module amagi manung the yori function to method however. So first input enter a number ama ko enter dole adu floating point on to you num variables the hapsale while true square root equal to square root of the number print the square root of the number is this num equal to float input enter a number ama enter toro hare if number is less than 0, print negative number cannot have square roots, break. Sigi program jina tawrisi kaino haragadi sigi program jina aingonda number am piro haraga number square root for neba. Yaraba. So let me run this program. Sigi program ji run to matam da koina kari thina gadi have kanda ena number am pirani mana square root am folani. Potpolu rega program ji loi deba. Number amago piro na dum ngai leba number piro dum ngai leba ko so let me run this program enter a number let me give 65 the square root of the number 65 is this pire si hot palo raga mana number among piro high for 45 among pira geba enter am namage 45 sigi square root amu hole numbers amago piro high leba sigi number piro some high le kedu bagino I get sigi while loop sina neba while true harabanina this loop will continue indefinitely until we come across the break statement jila hangi heading karam kanda lakani num less than 0 hadi when we input a negative number this loop will break and we'll get negative numbers cannot have square root have output se panganeba so I say da say 19 pisalage 19 pisalage magi square root follow kani number am piro adum high layer neba aduna ina break to ge hadi I have to give a negative number so negative 2 pisalage minus 2 pisalage then adu kedoroni num will be less than 0 wedani ko as a print negative numbers cannot have square roots ma print or money adu break to grani ko so let me press enter the negative numbers cannot have square roots haramaga says haramaga mana break to so this is how this particular program works adu sigidi ga sagi aina haiba sign gi series to yeng kanda yam laina understand to ngam gani ani ko adu hojik masigidi matam leselaktrabanina I think I'll stop